Good afternoon, chemistry students. Today we're going to do a deeper dive into understanding how acids and bases actually work. So in the past few days, we've been looking at some examples of acids and bases. For example, a common acid we've been using is vinegar or acetic acid, and a common base we've been using is baking soda, which contains sodium bicarbonate. And we've been looking at some of the properties of these acids and bases, how they can affect things like taste and things like baking, and how they might even react with each other. But today we're going to really learn in more detail how acids and bases react in water. So first we've got to think about water itself. So I got some water in this bottle here, and water probably has the most famous chemical formula in the world, H2O. And that chemical formula stands for 1 part oxygen and 2 parts hydrogen. All right. So something you need to know about water is that sometimes water splits up into 2 pieces. So sometimes H2O can split up into 2 pieces. One of those pieces is called OH minus. So one of the oxygen and one of the hydrogens break off with a negative charge. That's what this minus sign represents. We call this OH minus piece the hydroxide ion. All right. The other piece that's left over is just one extra hydrogen. So that because the first piece has a minus charge, the other one has to have a plus charge for it to balance out because water is neutral. So we've got the hydroxide ion over here, and then the other piece is the hydrogen ion, or also known as a proton because it's just one proton. So hydrogen ion. But this hydrogen ion doesn't usually stay alone by itself for very long. It usually finds another water molecule to bind with, and then it adds its hydrogen to that water. So H2O goes from H2 to H3O. So H3O, and now it has a positive charge because that hydrogen ion brought along a positive charge with it. So this new piece is called hydronium ion, and it's represented by the chemical formula H3O+. So we started off with water having a formula of H2O. Water sometimes splits up into 2 pieces, one of them being the hydroxide ion, OH-. The other, H+, which combines with water to create hydronium ions, or H3O+. So in normal water, the concentration of hydronium ions, H3O+, is always going to be the same as the OH- ions, or the hydroxide ions. So when the concentration of each of these is equal, that means we have a neutral solution. So this solution is neither acidic or basic. It's right in the middle. It balances out. It's neutral. So regular water is going to have an equal amount of each of these two. Equal part hydronium and equal part hydroxide ions. And in case you're wondering what these brackets stand for the concentration. So whenever you see these brackets around a molecule, you should know we're talking about the concentration of each of these. So in a neutral liquid, the amount of hydronium ions and hydroxide ions have to be the same. All right, so use this video to answer questions 1 through 8.